Have you ever watched someone crunch a massive number in their head and just thought, okay, they're definitely a wizard? Well, I've got a secret for you. Today, we're going to unlock how to multiply huge numbers completely in your head, literally faster than you can pull out your phone, unlock the screen, and open the calculator app. No magic required.
So, to kick things off, we need a quick baseline of your current mental math speed. I want you to try and calculate this in your head right now. What is 35 times 11? And hey, try to do it without reaching for a pen, and don't even think about how you'd write it out on paper. Just in your head.
The answer is 385. Now, if that took you more than, say, 3 seconds, or if you just completely gave up, honestly, do not worry at all. By the end of this explainer, you are going to possess a mental superpower that makes calculations exactly like this one completely effortless. 0 to hero for sure.
Okay, here is the secret. Multiplying literally any two-digit number by 11 relies on a ridiculously simple three-step method. Step 1. You just take the two digits of your number and split them apart. Step 2. You add those two digits together. And Step 3. You just drop that new sum right into the middle. That is the whole shebang. No long division, no carrying over multiple rows, just basic single-digit addition. You can see how brilliantly fast this is when we actually apply it. Let's take 23 times 11. You split the 2 and the 3, you add 2 plus 3, which is 5, then you drop that 5 right in the middle, and boom, your answer is 253. It's crazy, right? Once you see the pattern, you aren't even really doing math anymore. You're basically just reading the answer.
Now, there is one slight catch here. You might be wondering, what happens if the two numbers you add together equal 10 or more? Well, it's incredibly easy. If the middle numbers add up to a two-digit sum, you simply drop the right digit in the middle and carry the 1 over to the left digit. So let's look at 78 times 11. You split the 7 and the 8. 7 plus 8 is 15. So you drop the 5 in the middle and carry that 1 over to the 7, which changes it to an 8. Just like that, it seamlessly turns into 858.
But the real magic is that this beautifully scales up to 3 digits. Imagine you have 234 times 11. You just take the first digit, the 2, put it on the far left, and the last digit, the 4, goes on the far right. For the middle, you just add the adjacent pairs together. So 2 plus 3 is 5, and 3 plus 4 is 7. Put those in the middle, and your answer is 2,574. Seriously, you just multiplied a 3-digit number by 11 completely in your head. Okay, so are you ready for your next mental superpower? Because multiplying by 11 definitely isn't the only trick in the book. Next, we're going to look at a strict, exception-free rule for instantly squaring any number that ends in a 5. You can honestly just go ahead and forget all the complicated multi-step math you learned in school for this one. Let's prove this with 75 squared. All you have to do is take the first digit, that's the 7, and multiply it by the next number up. So 7 times 1 higher is 8. 7 times 8 is 56. Then you literally just stick a 25 on the end. That is it, 5,625. Or say you had 35 squared. It's 3 times 4, which is 12. Stick a 25 on the end, and you get 1225. It's like a math cheat code. Advanced techniques, cross-multiplication, and quick division. Now that you've got the basics down, we're going to step it up. We'll look at the methods competitive human calculators actually use to handle massive numbers and lightning-fast quick division. And yes, there are totally global competitions for this. For general two-digit multiplication, the pros use a method called vertically and crosswise. You know how standard math makes you write out multiple rows and add them all together? Well, this method drastically reduces those steps. Let's take 24 times 12. First, you multiply the right side vertically. 4 times 2 is 8. Then you cross-multiply the diagonals. So 2 times 2 is 4, 4 times 1 is 4, and add those together for the middle, which gives you 8. Finally, multiply the left side vertically. 2 times 1 is 2, and your answer is 288. Now, I know it sounds like a few steps right now, but with a little practice, it really collapses into a single flowing mental thought. You might be wondering, where do these incredible shortcuts even come from? Well, they heavily contrast with our standard step-heavy Western math, which are actually learning are principles rooted in ancient Indian Vedic mathematics, which were summarized beautifully in the early 20th century from texts dating back thousands of years. There's also the Trachtenberg system, which is another phenomenal framework for rapid mental calculation. Both of these rely on brilliant mental efficiency rather than just brute force calculation. And the crazy thing, they don't just stop at multiplication. These exact same systems provide frameworks for quick division too, allowing you to seamlessly pull apart large dividends in your head without ever needing to draw one of those awful long division brackets.
So why do these ancient methods feel so much faster than what we learned in grade school? It really all comes down to something called working memory. Your working memory is basically the tiny amount of information your brain can actively hold on to at one single time. Standard math totally clogs up your working memory with carrying digits, placeholders, and multiple rows. But these tricks, they're so effective because they specifically bypass that bottleneck. They drastically reduce the cognitive load on your working memory so you can just compute.
The brain science inside a math prodigy's mind. Let's shift our focus for a second from the math itself to the fascinating neuroscience behind it. Researchers over at Oxford University actually studied the minds of high-functioning math geniuses, and I'm talking about people who can literally calculate division to 10 decimal places in under a minute just to see what is happening on a biological level.
What the Oxford researchers zeroed in on was E/I balance. This is the delicate interaction between the gas pedal, which are your excitatory neurotransmitters, and the brakes, your inhibitory neurotransmitters. In typical brains, we have a certain baseline balance of this, but researchers found that exceptional mental calculators actually exhibit a reduced frontal excitation and inhibition balance. Basically, their brains physically and chemically optimize to process these numerical networks with almost terrifying efficiency.
But please, don't let the brain chemistry stuff intimidate you. I really want to reinforce what one of our sources perfectly states. That isn't a magic trick. It isn't a memory feat. It is the result of a different way of seeing numbers. These top performers aren't performing magic. They're just optimizing their brain's network, using the exact same shortcuts we've been discussing today, and absolutely anyone, including you, can adopt these shortcuts.
In fact, I want you to prove this to yourself right now. Go ahead and pause the explainer. Test out your brand new multiply by 11 superpower on these practice drills, and then check your answers. Just notice how much faster you already are compared to literally 10 minutes ago. It's awesome. Now, to really make these mental pathways permanent, here's your game plan. When you start, whisper the digits to yourself to build the habit. I know it feels a bit slow at first, but it totally builds the foundation. Drill in spaced bursts. A quick 2-minute session today is way better than cramming for an hour on Sunday. Practice daily. And hey, if you want to keep expanding your cognitive toolkit, be sure to subscribe for more mental math tricks and deep dives.
I want to wrap up this explainer by leaving you with one provocative question to think about. You literally just learned how to bypass years of traditional math education to calculate massive numbers instantly. If you can completely rewrite how your brain processes numbers in just a few minutes, what else is your mind truly capable of? Keep pushing those boundaries, keep learning, and I'll see you in the next explainer.